So this is lesson 85 in Algebra 2, Systems of Nonlinear Equations. What we're going to do in this particular lesson is look and see where two figures intersect on a graph and call those intersection points our answers. Alright, a nonlinear equation. What we've got here is a conic section, which is what that is right there, all of these here. This has a particular name. Gosh, I don't remember what the name is of it right now. You'll get it in college algebra anyway, but for right now, we won't worry about it. But what we're doing is looking at a conic section, like right here, this little cone, and we're going to cut that cone into four possible pieces here, and they're going to give us figures. If we were to take a plane and cut that cone exactly right there, and we look down on it, we're going to get this circle. If we use this plane and we cut it at a little bit of an angle, we get our ellipse. And if we were to take this and cut it so that the bottom goes, the plane goes through the bottom of the cone here, right there, we get a parabola. And if we take a cone and put it vertex to vertex, like right here, and we put a plane down through it, we get here, let me do it in red, we get here, and we get here when we look from this direction, and that is a hyperbola. Alright, so those are our four different options we get when we cut a conic section. And so what we're going to do is we're going to look and see what happens as we cut that conic section and get certain figures and how those figures intersect each other. So the picture on page 351, we've got a graph here, and we've got a circle, and we have a line. So we have an equation for this circle, and we have an equation for this line. Now where those x's and y's are the same is going to be where those two figures intersect, and that's what we're going to be looking at today. Just very, very briefly. We'll get into a lot more detail on how all this works later, but let's look at to solve a system of equations where one or both of the equations are not straight lines. They may be something different, like a parabola or a circle or something like that. Alright, what we've been doing up to this point is we've been using elimination or substitution to solve these. We would either set this bottom one equal to y and then plug whatever y equals, so we'd plug that in for y here, and we'd have all of our x's on top, and we'd solve it. Or we would make, let's say, if this is a negative y and this is a positive y, we would add them together and it would eliminate the y's. Alright, problem is these doggone exponents right here make it so we can't do that. So we're going to have to do something with those exponents in order to make this doable. So what we're going to do is we're going to take this bottom equation here, and we are going to set it equal to y. Okay? So we have y equals 2x minus 3. Now we're going to substitute. And it says wherever there's a y, we're going to put 2x minus 3. And what's being done to that y? It's being squared. Alright, so now we go ahead and do the FOIL method with 2x minus 3. And we're going to put that in parentheses here. And then we're just going to go ahead and solve it. Okay, so I added these two, subtracted that from both sides, and got 0. I'm going to factor out an x. And x equals 0 for right here. Or x equals 12 over 5. So those are my two x values. Alright. Then I take my 0 and I plug it in up here, and I get 2 times 0 minus y equals 3, or y equals negative 3. So when x is 0, y equals negative 3. Then I take the 12/5 and I put it in here for x, and I get 2 times 12/5 minus y equals 3. 24/5 minus y equals 3. And then subtract 24/5 from both sides, change the sign of my y value, and I get a y equals 9/5. So when x is 12/5, y is 9/5. So the two figures cross at two places, at 0, negative 3, and at 12/5, 9/5. And if you look back on the top of page 351, it gives you a circle and a line, and where those two cross are at 0, negative 3, and 12/5, 9/5. Alright, so let's look at example 85.2 and we'll be done. Okay, so let's kind of look at what we've got here. We've got two variables, a b and a td. So we've got one variable b and the other one is t of d. Okay, t of d, again, even though there's two letters there, it's one variable because this here just gives you specifics. So let's say we're looking at the time that Don ran or something like that. That's what that is being specific about. So we have t, d, and b. Alright, so let's look at what we've got. We don't have any exponents on here, so that's good. One thing that we do have is we have a plus 5td and a minus 5td, so really we could just add those and get two btds. These would cancel, and that would give us 40. So btd equals 20. Okay, it looks like it's really easy, but the problem is we have two variables multiplied give us 20. So I have not really found what one of the variables are yet. I just know that both of them multiplied give me 20. So now we have to use 20 as a replacement for btd in one of these equations up here. So let's put 20 in for the first, for the btd, and then we've got plus 5td equals 25, and so we have 5td equals 5, and td equals 1. So we know one of them. We know td is 1, but we don't know what b is. So we can plug that 1 in for this equation, this one, or gosh, even this one. Let's use this little one because it's got the least amount of stuff in it. So b times, my td is 1, equals 20, therefore b equals 20. So td is 1, b is 20, and that is it for that lesson. Not really a whole ton of stuff there. So that's lesson 85.